Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 22, we will continue with primary and secondary waste collection. The different concepts that we will cover are: for primary collection, vehicles and equipment required; secondary collection, vehicles and equipment. Then we will talk about transfer stations, types of transfer station, some case studies on transfer station, and finally suggested collection, transportation, processing and disposal plan for MSW for ULBs as per CPHEO guidelines. So, as we have already discussed that door-to-door collection or primary collection, we go for different kinds of collection systems. One of them is of course door-to-door collection within primary collection, and door-to-door collection usually takes place for segregated waste, and there are different types of vehicles which are utilized for this. Either we can go for containerized handcart or tricycles with or without hydraulic tipping containers. That means tricycles, but at the same time they can tip, or they may be just fixed containers. Light commercial vehicles with or without hydraulic tipping containers, or mini trucks with international standard garbage collection bins. So again, mini truck is a little bit maybe of larger size than the light commercial vehicles, and also they have got, instead of this tipping containers, they have got separate bins within that, and then the bins gets filled as per different kinds of segregated waste. Now this is for door-to-door collection, but for curbside collection, if there is that kind of a system, then compactor vehicles are utilized, some tipping vehicles can be utilized. Or if like door-to-door collection or block collection, we can go for this kind of vehicles. For curbside collection, we can go for this kind of vehicles. Even for community bins collection also, we can go for this compactor vehicles or tipping vehicles. Now, selection of vehicle, as we have discussed earlier, as per waste composition and quantity and frequency of collection, climate of that area, topography of that area, street width, building density, and of course repair and maintenance facilities for those kind of vehicles. If this repair and maintenance facilities doesn't happen, is not there, then there is no point of buying that vehicle. Similarly, the frequency of collection, we have to actually make a choice on how frequent we should collect, and also the vehicle design. This should go hand in hand, right? For example, if I tell you that I collect waste every 2 days, that means obviously the waste content would be doubled, right? So that means if a normal household generates 2 kilograms of waste, then if it collects every 2 days, it will become 4 kilograms of waste. Then what happens? Now suppose the capacity of that particular vehicle is 50 or 40 kilograms, suppose. So that means after 10 houses, this vehicle will get filled, because each house is generating 4 kilo. Then it has to again take this vehicle back to the secondary storage and unload the vehicle, and then again come back. If the distance of the secondary storage is too far away, then you will lose a lot of time. Instead, if you could have done daily connection, then there are 2 kilograms of waste per house. So instead of 10 houses, you will be able to collect from 20 houses. So in that case, the time spent on collecting waste is more than the traveling time of the vehicle from that particular area to the transfer station. So we have to make these choices, right? What should be the frequency? Then the other problem is waste that is generated, like organic waste may be 60%. The inorganic waste may be only 30%. The rest is hazardous waste or mixed waste. So in this case, the organic waste is double. So if I design a vehicle which has got two equal divisions, the two equal one segregation in between that container, then of course the organic waste part will get filled faster because it is double than the inorganic than the non-biodegradable part. So this needs to be considered, right? So accordingly, we have to take a call on how many divisions I need to make, what should be the design of that container, and so on. So usually we see that for containerized hand cut, when we use hand cuts, we go for containerizing it, or we put multiple containers. Now, if the waste is 50-50, that is organic waste and biodegradable waste and non-biodegradable waste is 50-50, then we can put 2 containers of biodegradable waste, 2 containers of this non-biodegradable waste. But if it is not 50-50, in that case, accordingly we have to design, or we have to select that so many containers of organic waste, so many containers of non-organic waste, right? So, in roughly what we see in containerized hand cut, usually 4 to 6 containers of 40 to 60 liter capacity is actually utilized. So, container color is as per the waste types. As you can see in these images, all these images you can see, like over here there are 3 blue containers, over here there are 2 yellow, 2 green. In this case, yellow is actually, green is for organic, yellow is for, this was earlier than before the rules came in. So then in this municipal body, they used to have green and yellow. Then the current rules states that we have to have non-biodegradable in blue and biodegradable in green. Accordingly, this is the final specification. But earlier we used to have this kind of colored containers. But you can see that there are 4 containers. Some places there are more than 4. So we have to decide on how many containers, of what size, and so on. And the size should be such that a person can easily handle that. That means he can usually lift it by his hand, or we have to design the containers in such a way so that those could be mechanically lifted, right? So the containerized hand cuts are suitable for narrow lanes. The design of standard garbage garbage bins should be standard sizes so that they could be handled by mechanical systems. And also this could be used for collecting street sweeping. So we can use this kind of hand cuts for also collecting the street sweeping waste that is generated. Bins for containers should be easily unloaded into secondary storage or transport vehicles. So these are some of the criteria for determining what should be the design of a containerized hand cut should be. Then comes tricycles. Now, as you understand, this could be a little bit bigger in size because here we are using a mechanical system so that people can pedal and can carry it. So instead of pushing it, so here the size of the vehicle is a little bit larger, and also the amount of load you can carry is also a little bit larger. So 6 to 8 containers of 40 to 60 liters capacity. These are faster than hand carts, and allows carrying of larger quantity of waste for a longer distance. So if the transfer station is a little bit far away, then probably we will go for this kind of hand carts, this kind of tricycles. And of course, here what happens, there is a person who will drive the tricycle, and then there is another person who facilitates the collection of waste from the door to door and then putting it back, right? So, or even there may be 2 persons collecting and 1 person driving the vehicle. Whereas for the hand cut, there could be only 1 or just 2 persons, okay? So that means as per the vehicle, the manpower also changes. So sometimes these tricycles can have a hydraulic tipping container instead of just standard bins, and also like you can see over here, there is a hydraulic tipping container instead of just simple bins. Or usually the containers are made of mild steel, they are epoxy painted, and size is something around 350 liters, which carries around 140 kilograms of waste per trip. That means in the normal hand cuts, maybe we can carry around 70, 80 kilograms of waste, whereas over here we can carry a little bit larger, which is 140 kilograms of waste. Then comes LCVs, mini trucks with hydraulic tipping containers, or they can be without tipping containers as well, but usually we design it so that they could be easily unloaded and all. Again, this kind of vehicles can only work at least 5-meter road width is there. If it is less than that, we will possibly go with tricycles. Capacity is much larger than tricycles, 600 to 900 kg per trip, unlike 140 kg per trip. So that you can understand that you can cover many buildings and all, or many collection points. So what it means is that if the density is low, then probably it's better to go with LCVs, right? Because there is significant travel involved in between the collection points, okay? Or suppose you are collecting the garbage from community bins, then also probably a LCV is better than a tricycles. But usually when we collect from garbage bins, we usually send even larger vehicles. So size up to 3 meter cube capacity. Load height is very important, because if it is too high, then it will be difficult for people to throw the garbage inside. So load height is around 1500 millimeter from the ground level. Some people also say 1.6 meter is the maximum height. Container is mild steel body with drainage tube and plug to prevent leak. Because it's a container, the moisture is there, moisture will try to come out during transport. So there has to be some sort of system, so that eventually this will be drained out when it is taken to a cleaning facility or to the final storage facility. So that's why a drainage tube as well as a plug is there to prevent leakage along the way. The tipper is attached to the chassis, and 4 openings, as you can see over here, there are 4 openings on 4 sides. And this actually helps to usually facilitates people to put in the waste directly, and central removable partition, which is first, so that segregated waste could be carried, like dry waste and wet waste could be carried in different partitions. So this is how this kind of system looks like, and you can see over here this auto rickshaw, or this with this small, this lifting, this particular hydraulic tipping container is over here, and it is directly, the waste is put in, the design is such that the waste could be directly transported into the metal container or this secondary storage container. So then also we can go with mini trucks with international standard bins. So the loading height is even lower over here, because we are using bins, and capacity of bins is 8 bins of minimum 8 to 40 liter sizes, and 4 green containers for wet waste, 4 blue containers for dry waste. Again, this could be as per the kind of waste that is being generated in that area. Now coming to equipment for primary collection, or just for this kind of systems, not only vehicles, we have to also think about equipments. As per clause 15 of MSW rules, duties and responsibilities of local authorities, it says that ensure that the operator of a facility provides personal protection equipment including uniform, fluorescent jacket, hand gloves, raincoats, appropriate footwear and masks to all workers handling solid waste, and the same are used by the workforce. So this kind of equipment has to be mandatorily provided as per MSW rules 2016. Now, when we talk about this primary collection, there is one concept called binless area or city. That means, as we were discussing in our previous lecture, then we can synchronize the transfer between primary and secondary collection, so that there is no requirement for secondary storage or secondary storage bins, right, or secondary storage depot. Now, why? That means the primary collection vehicles will come, as I was showing you in the last slide, that the primary collection, this auto rickshaw will come, they will till the garbage directly into the bin, and the bin would be taken away by the waiting vehicle, right. So that means there is no requirement for secondary storage. Secondary storage collection vehicles are parked at fixed locations, so they are waiting, and logistics and planning in making adequate vehicles available, that's the biggest challenge. That means we have to have lot of secondary storage vehicles available all the time, and we have to really plan that. That means when the garbage is going to come from primary collection, and what is the timing of the secondary storage vehicle to come over here. So all this logistic planning has to be done. So some cities have tried this, like Kochi and Nasik Municipal Corporation has tried this, but obviously this will increase the size of the secondary collection fleet. Now that is not good, because secondary collection vehicles are larger, more, you have compactor vehicles and other kinds of expensive vehicles, so it will increase the cost of waste collection. So that's another thing that we have to be considered about. But the benefits are, obviously there is no spillage, there is no, unsightly areas, everything looks nice and there is no contamination of any kind. So that improves health of the urban area. Segregation level also has to be considered. Now coming to secondary collection vehicles and equipment, of course these are larger, vehicles. The basic system is a tractor trailer system, which is still found in many, smaller cities or many semi-rural areas, where usually we have a agricultural tractor, as we know that it has got 2 wheels, and this tractor is employed there, the wheel comes over here, and then there is a trailer at the back. This trailer is loaded, and for every tractor there could be multiple trailers. That means one trailer remains waiting at the secondary storage point, and this tractor comes in, puts the empty trailer and takes the loaded trailer to the landfill site, unloads it, and again brings back the empty trailer. So that's what goes on. So usually trailer capacity is around 6 meter cube. Transported when the trailer gets full, it is transported by a tractor. Speed is something around 15 km/h, because tractors are not designed for traveling fast, but they can usually landfill sites in this kind of areas, they are more very undulated terrain and all, so a tractor can easily negotiate that. Theoretical trailer requirement is 2 per tractor, one stationary at the transfer point as we have just discussed, and the other is in the travel. Other is actually being transported to the landfill site. One trailer, this can vary, but we can say that one trailer can be exchanged 6 times a day. It can support at least 40 collectors, waste collectors for primary collection, serving around 45,000 people in an area of 1 square kilometer. So this is just, this is a very specific case. You can take it as a case study. So for 45,000 people, 40 waste collectors are required. All these waste collectors bring the waste to the secondary storage area, which is a trailer, a waiting trailer, and the trailer is exchanged 6 times a day. And if the density increases, of course, that means more amount of waste would be generated. If that is the case, then one trailer is not good enough. We have to add further trailers. Whereas if the density is low, then that means we have to have multiple transfer points. That means if same number of people live in this area and the same number of people live in this area, of course, here we are putting a transfer point over here, because the rest is collected via primary collection from the surrounding area. But because this area is very sparsely developed, so we have to have 2 transfer points, one for this area and one for this area. But the number of collectors will remain same, because we are increasing the transfer points, but the number of collectors will remain same, and we may have to increase the number of trailers as well. So these are basic systems which you can see in some areas, but usually as per MSW rules, also we have to move beyond this, and we have to move to better vehicles, better systems. We also see this kind of open lorries in some urban areas as well, but again this is as per MSW rules, this is a band. You have to have covered containers, covered vehicles, so that waste doesn't spill. So earlier we used to see this kind of vehicles, but now we see other kinds of vehicles, like we have discussed this skip trucks or dumper placers. That means we have this kind of garbage bins at different locations, at secondary storage or community bins and so on. This skip trucks transport the skips, which are nothing but the dumper bins of different sizes. The skip sizes could be 2.5 meter cube, 3 meter cube, 4.5 meter cube, 7 meter cube. Accordingly, the vehicle sizes also will vary. Usually this kind of trucks can make 5 to 6 trips in 8-hour shifts, provided the trip one-way distance is around 15 kilometers away. This could be also used for C&D waste transportation. The C&D waste could be also stored in this kind of containers and then transported. Empty skips placed at storage depot and full skip lifted and transported. So the same system, we keep the empty container at the storage depot, and the filled container is being transported on the way. So the vehicle is utilized continuously, whereas it can bring in the empty container and take the filled container. And if possible, the same vehicle can serve multiple sites as well. Lifting mechanism should be such, like as you can see over here, there is a lifting mechanism handling. This can handle waste of 1000 kg per meter cube density. So as per the volume and the density, the weight of waste will vary, and accordingly this has to have the capacity to lift waste of this kind of density for whichever size of vehicle we are considering. Twin dumper placers are also used, like over in this image you can see twin dumper placers. That means 2 containers can be lifted into this particular vehicle. Then refuse collector vehicles are also other kinds of vehicles which can be without and with compactors. Compactor means there is a mechanical, like over here, this is a compactor truck. At the back of the vehicle, you can see that there is a mechanism which pushes using a hydraulic system. It pushes on the waste and compresses it, right? So that's a compactor truck. So that air is moved out, and because air is removed, then we can store more amount of waste. But there are also vehicles which are without compacted systems. So in this case, what happens? This kind of vehicles are of capacity 6 to 15 meter cube. Varying sizes vehicles are there. The bins could be directly loaded via this hydraulic system. If you remember from our previous module, we have shown an example on those things. The vehicle comes in, it attaches to that particular, this is the vehicle. It has got a loading arm. You put in you fit the container over there. It lifts over here, puts the garbage inside, and again places it back over here. So this kind of vehicles are now being currently replaced by compactor trucks, and lifting is done via hydraulic system. And I missed on this. This is a hook loader or hook lifter. Same as the previous one where we were using the skip loaders and all. This is the same thing, but for larger containers, we use this kind of a chain kind of system for loading or lifting this kind of garbage containers into the vehicle. Then comes the real loading compactor trucks. As you can see in this image, there are different varieties of this, different sizes of this. From storage depot to this kinds of trucks are used to transfer garbage from storage depot to larger transfer stations or treatment centers or disposal sites. This loading hopper, this has the ability to unload tipper vehicles and handcarts. So as we are discussing over here, there is a loading hopper. So the handcarts or tipper vehicles can unload their garbage over here, and this actually is loaded into the vehicle. And compaction, then there is the compactor inside which can compact the garbage to 800 to 900 kilograms per meter cube. Then there are different sizes of these vehicles, small ones, medium ones and large ones. As you can see that it can starts from 5 to 6 meter cube, which comes to around 4.5 to 5 tons of waste per trip, to around 12 to 16 meter cube or 10 to 12 tons of waste per trip. So as per the requirement for carrying waste, we will decide on which kind of a compactor we will use. Then sometimes we can also use light commercial vehicles with tipping float, or it could be also larger vehicles as well. Problem is they do not allow direct transfer of waste to secondary collection vehicles. In case of LCVs that we have learnt earlier, sometimes they do, sometimes they don't do. Simple hydraulic tipping trailers to have this is only helps in manual automatic unloading. But of course, if they unload it in the ground, manually we have to load it to the next vehicle or to the compactor unit or wherever it is. In case of split level sites, that means where the vehicle unloads their waste at one level and the waste falls to another level, maybe a container or another vehicle waiting at a lower level. There, if this waste is being unloaded like this, there probably this kind of system would be beneficial. We will show in some examples. Now, coming to after vehicles, then we will talk about transfer stations. That is, we have talked about in tertiary collection systems where we have to provide transfer stations if the distance of the final disposal site or the waste processing centers are far away from the collection points, right, or the secondary storage points. So transfer stations are required when cost of direct haul to disposal or treatment site by secondary collection vehicles is greater than cost of haul by secondary collection vehicles to transfer station, because the alternative is we have to use these vehicles to carry it first to a transfer station, plus additional haul using large bulk haul transfer vehicles to the disposal and treatment site. So in the second stage, we obviously will use larger vehicles to consolidate on the waste. Cost of infrastructure and transfer facility. You have to set up a transfer station and a lot of infrastructure for that, and modified infrastructure at processing and disposal site to handle this new large bulk, transport vehicles. So if both this cost is justified, then only we will go for a transfer station. That means if this additional cost is justified, then only we have to go to a transfer station. Now, why the cost would be different? For short haul transfers, that means if I don't use this transfer station, this will require more number of vehicles and drivers, and we have to pay salary of drivers, and each of these vehicles will cost money plus the fuel they will consume. Similarly, for long haul transfers, this will involve less number of vehicles and drivers. But fuel use and capital cost varies as per vehicle size, so we cannot exactly say that which system will consume less fuel or which system will cost less, because maybe one large vehicle will cost more than two small vehicles, or how many large vehicles are required. So first this should be determined, then only we can determine the final cost. So cost of haul is running cost of vehicle plus cost of manpower plus capital cost of vehicle. So using these three criteria, we have to determine which system is beneficial. And rule of thumb is large cities where disposal processing sites is greater than 15 kilometers or 30 minutes away from the collection area, we set up transfer stations. So again, this is a rule of thumb, but that doesn't mean that we have to follow it. You can actually do this cost calculations and we can determine. Transfer stations are also known as tertiary storage depot, and sometimes they also include material recovery facilities. So sorting of recyclables for further processing or for sending to the market could be done at these transfer stations, because this is where all waste is coming. We can do sorting and all these things, and again we can send the sorted waste as per, we can send them to the market, we can send them to some waste processing facility, or we can send them to the final landfill site. So it's a transfer station is a suitable area where we can do this. And usually we use larger containers in transfer stations. So that container size ranges from 15 to 25 meter cube. And as you understand, this is bigger than the compactor trucks that we have discussed earlier. And so we use a different sort of, larger trucks or larger containers for hauling for this sort of large bulk haul transfers. So there are two types of transfer station based on the way the loading unloading arrangement is done. As you can see, the first one is known as direct unloading. It's a two-level arrangement, and there is a ramp is provided, like over you see, this is a vehicle which has brought in the waste. It has got this tilting mechanism. It is putting the waste into the waiting vehicle over there, or this waiting container, or that this may not be the vehicle, this may be just the container, and then the container will be lifted into a vehicle. That can happen. So let us assume that this vehicle has gone above. How it has gone? Of course, it has used a ramp to go to that particular spot. So collection vehicles drives up a ramp and using tipping gear discharge waste to a waiting vehicle which is larger in size, and this is known as the direct transfer system. Directly I am loading into this particular vehicle. And usually this kind of system is suitable for small scale, which is less than 300 tons per day. Otherwise what happens, because this is a direct transfer, that means these vehicles are waiting. These smaller vehicles are coming and these vehicles are waiting. So this vehicle will wait till it gets filled. So when all these small vehicles come at a single point of time, suppose waste collection starts at 8 o'clock in the morning, and then by 11 or 12 o'clock this vehicle starts coming. You will see that the maximum peak hour happens for only 1 or 2 hours, and that's around 12 o'clock or 1 o'clock, something like that. So we require a lot of these larger vehicles during this time. So that's a inefficient way of working, right? Because for the other times of the day, these vehicles would be not utilized. So we have to, only in case of very small load volumes, this is fine. Because in that case, a couple of vehicles will be able to take care of the entire load. A few vehicles will be able to take care of the load. But when the load volume increases, we really need to optimize this particular system. Most collection vehicles start arriving within a limited time window of 1 to 2 hours. So that's the problem, and that's why you need to have these vehicles working. But the benefit of this system is infrastructure cost is low, since only civil works and stationary equipment are required. So that's the benefit of this particular system. Now the second system is unloading to storage system. As you can see that it could be a 2 or a 3 level arrangement, right? I will show you a 3 level arrangement later on in the next slide, but in this 2 level arrangement, collection vehicles discharge into a storage area. Suppose collection vehicles comes and they discharge into this particular area, and then storage area and unloading area may be at the same level or different level. The storage area, this is the storage area where garbage is stored. and the unloading area may be at the same level. That means physically you have to lift it into the vehicle, or it could be at a, or we can use some bulldozers or something to lift the garbage into the vehicle, or it could be at a different level, like we can push the garbage using this kind of loaders into that particular container which is at a lower level. So this kind of system can be there. Storage size adequate for peak load for one day. So that means the storage area we have to provide some storage area for waste, and that has to take care of peak load for one day. Instead of directly putting it into the container, we can first put it into a hopper or a conveyor, and then as per the requirement, when this container comes in after delivery, maybe the container returns or the vehicle returns, then we can place the container, open the hopper or the conveyor, and then can carry the garbage and load the garbage into this particular vehicle. So waste could be either pushed by a bulldozer into this particular hopper or this particular conveyor belt, or it could be picked up by a crane and also put inside this particular container. Some basic waste sorting could be done in this particular, this collection system. So as you can see over here, the garbage tipper has come. It puts the garbage into this particular hopper. The hopper is stopped, and then this is a compactor where this is a static compactor where the garbage is compacted first. This hopper allows the waste to go down, it compacts it and then loads it into this particular container, which is eventually taken up by this hook loader. Using hook loader, we load it into this particular truck, and then the truck carries on to the landfill site, right? So this is the basic system. So this is we are directly putting it into the hopper, or in some case we can use this kind of bulldozers to push the garbage into the hopper, or we can use cranes to lift the garbage. It all depends on how you are doing the loading unloading arrangement. So in 2-level system, we have to use a crane or a bulldozer, but in 3-level system, like over here, you can see that the waste is unloaded at this particular level, and it falls to this particular level. This is a storage pit. From here, I can push the garbage, or using conveyors, I can send the garbage to this area, and then you can see that there are this cranes over there which is lifting the garbage and then putting it into the waiting container which is over here, right? And this also has got weigh bridges. We can weight how much amount of waste is being loaded, and accordingly, once the load is filled, we can send the vehicle to the landfill site. So this is a 3-level arrangement, and we can go both for 2-level and 3-level arrangements. So these are some images from the Municipal Corporation of Faridabad. You can see that this is how the garbage is being unloaded into the hopper, and this is how the hopper looks. This is the compactor below it, and then this is the vehicle which is bringing out this vehicle means the container which is being loaded by this particular compactor, and this is being lifted into this particular vehicle and then carried forward to the landfill site. Now, the second case study is about Coimbatore City Municipal Corporation. Here in Coimbatore, they have set up 3 transfer stations, and the storage area that they have created in this transfer station is for 1 hour, peak hour of course, and it's on the upper deck. So it's a split level site, and it's on the upper deck, and the capacity is 30 tons per hour. So that's the area of storage. So as you can see that this is a ramp. This is the Coimbatore station. This is the ramp. The vehicle goes up. So this at the top there is this platform where you store garbage, right? And then there is a compactor, 35 tons per hour capacity compactor is there, and a hopper is there, and this compactor pushes the waste from the hopper into the container. The size of the container is 20 meter cube, and this could be lifted by a trailer type hook loader into the vehicle. And weighbridge is also there, which is of capacity 40 tons, that can weigh the weight of that particular container and the vehicle. And the overall design is designed for 200 tons of compacted waste per day. And the area required for this site is around 1.55 acres. And as you can see, earlier the site used to look like this. Again, people used to use a split level system, but it used to look very ugly, aesthetically and hygienically not good at all, as this was the situation earlier, and this is the current situation, which has made the entire operation very, very efficient. So Then coming to certain suggested collection, transportation, processing and disposal plan for MSW for ULBs. This is again given by CPHEO, and again, I mean, these are suggestions given. Either you plan your own system, you can do all the calculations on your own, or these are very crude suggestions which are given. But again, if there is a lot of difficulty in collecting data, lot of difficulty in manpower, do this kind of calculations and all, at least to set up a basic system, you should follow this kind of rules. So here, first, based on different population sizes or different ULB categories like municipal council, municipal corporation and so on, we can decide on what sort of system we will adopt. For example, for a population of 50,000, which generates around 2 to 2.5 tons per day, per 10,000 population, this is the waste generated per day. We can go for D2D collection using handcarts and tricycles, and bin size could be 10 to 15 liters. Community bins of 60, 120 to 40 liters and 1.1 meter cube capacity could be provided. Bulk generators capacity of bins should be 120 to 240 liters, and contract will be given to private firms, resident welfare associations or NGOs. And similarly for secondary collection, so this is for primary collection. For secondary collection, 3 to 4 meter cube containers, 4 per square kilometer, that for every square kilometer there are 4 such containers, or 1 per 5,000 population. And tractors having container lifting devices could be also utilized. And finally, we can go for decentralized composting or biogas for biodegradable and recyclable waste, and town level processing in absence of decentralized facility, and 1 tractor per 10,000 population for transporting this waste. And only inert waste is transported to the regional landfill facility. So that is a suggestion given for smaller towns of around 50,000 capacity. For little bit larger town, 50,000 to 1 lakh, we see that waste generated increases to 10 to 30 tons per day. Idea is 250 grams per capita per day is generated. You multiply, you get this kind of figure. 80% of households should be covered by tractor or LCV for D2D collection. So either a tractor trailer can come door to door, or a LCV can come door to door collection, and 1 vehicle per 1500 people, and for or households or shops and so on. So these are the different generators. So we can decide on so many LCVs per so many households or so many collection points. And 20% of the households should be covered by tricycles or handcarts. Why? Because not everywhere this kind of LCVs or trailers, tractor trailers can go. So that is where this tricycles has to go. So that's an assumption that 20% would be adequate for this size of a city. And direct transfer from tricycle to tractor or LCV to processing facility. So that means the LCVs or the tractor trailers directly take the waste to the processing facilities, and this D2D system of handcarts and all will transfer the waste to these particular vehicles. And for secondary collection, 100% street sweeping collected in handcarts, 3 to 4 meter cube containers placed at every 4 kilometer square or 1 per 5,000 population, lifted by tractors or twin bin dumper placers. So that means that street sweeping waste and all these things are again taken from this community bins or these bins that we place at certain parts of the city directly to the final disposal points or to the processing centers. Whereas for door-to-door collection and household waste is directly taken by LCVs and all from these areas to this particular disposal points. 50% decentralized processing if suitable space is available. Domestic and trade waste at centralized facility with resource recovery if space is not available. And inert waste and street sweeping and silt from drains also goes to landfill. So that is a little bit different from the initial system that has been proposed. Now, if I go to larger cities of 1 to 5 lakhs or even 5 to 10 lakhs, you see that 75% D2D collection is via LCVs, 25% is via tricycles and handcarts, and direct transport if distance is lesser than 5 kilometers. So here there is an option. Earlier it was direct transport. Here it's not direct transport. If it is less than 5 kilometers, it's direct transport, or using compactors if longer. Compactors could be deployed based on volume or weight of waste, right? So that's how it has been decided. Street sweeping and silt collected in containers, handcarts and taken to secondary storage 1.1 to 4 meter cube containers, and again placed at 4 per square kilometer. Same rules are there, and 100% D2D collection processed at decentralized sites composting, biogas and RDF facilities may be created for these urban areas. And same, the inert waste, street sweeping waste, silt goes to the final landfill site. And above 10 lakhs, more or less everything is same. Only large containers of more than 10 ton capacity with hook loaders may be deployed for bulk transfer of waste. So that's addition. In addition to all this, this is extra. And dumper places and compactors to be deployed based on volume and weight of waste. And finally, in addition to composting biogas, we are proposing RDF facilities, waste to energy facilities, power plants may be installed for converting from waste to energy, as because power plants are only viable above 500 tons per day. So this is, we will discuss what sort of processing facilities in later modules, but at least this is one solution which is given by CPHEO for setting up a basic waste management system for different urban areas. So these are some of the references you can use. To conclude, MSW collection and transportation needs to be synchronized among the different stages of waste collection and transportation, and vehicles are selected as per waste composition and quantity, frequency of collection, topography, street width, building density and repair and maintenance facilities. Thank you.